Already we discussed 44 organic reaction in our classes. By this video, discuss rest of the organic reaction. Number 45. I get this organic molecule. We called as this molecule nitrogen substitute amide. Nitrogen substitute amide. We can hydrolyze nitrogen substitute amide using acid or base. First talk about how to hydrolyze using acid. When we put any acid for nitrogen substitute amide, between carbonyl group and nitrogen group, this bond, this sigma bond break. After break this bond, this carbonyl carbon reduce the one bond, nitrogen reduce one bond. Therefore, this carbonyl group attached to OH group and nitrogen group attached to hydrogen. Normally, when we do in hydrolyze, water molecule attached to four organic compound. When attached the water molecule, H plus attached to one part and OH minus attached to another part. In this one, OH minus attached to carbonyl group and H plus attached to nitrogen, form carboxylic acid and normally amine. Write the product for this example. Write the product for this example. When add acid, what is the product? Let's see how to what is happening when we done base hydrolyzing. When we use the base, same mechanism can be seen. First step, first between carbonyl group and nitrogen group, this single bond break and attach the OH group for carbonyl and hydrogen attached to nitrogen. First step, form carboxylic acid and normal amine. We studied carboxylic acid again react with base, form carboxylate anion. Therefore, final product when we doing base hydrolysis for nitrogen substitute amide, carboxylate, aniline and amine. We can't get carboxylic acid because when form the carboxylic acid, again this carboxylic acid react with OH minus form carboxylate anion. Write the product for this example. After write the product, send me answer. Do this conversion. Do not use any other organic compounds. After doing this one, send me the answer, your conversion. Let's see next reaction. This molecule called as alkyl halide. This one have one halogen group. I get this molecule. This molecule have two halogen group. Sometime two halogen group can be attached one carbon atom. I add the alcoholic KOH as region for this alkyl halide. When we add alcoholic KOH for alkyl halide, remove the HX molecule. This halogen group and hydrogen group release as HX. In this molecule, hydrogen release, this halogen release with this one hydrogen. We should know how to select where the hydrogen remove. We used to for this Seitz-Sheff law. Seitz-Sheff rule. We used to Seitz-Sheff rule determine the which hydrogen release with halogen group. According this rule, removed hydrogen, remove of hydrogen from the carbon that has the small number of hydrogen. According to the set rule, hydrogen removed from the from the carbon that has the small number of hydrogen. Now we can select where is remove the hydrogen in this molecule. This halogen can be release this hydrogen or this hydrogen. This carbon attached to 2 hydrogen atoms and this carbon attached to 3 hydrogen atoms. Here this carbon attached hydrogen 2, this carbon attached hydrogen 3. According to the set rule, hydrogen released from lowest number hydrogen carbon. Therefore, this hydrogen released with this halogen group as HX. This carbon reduce one bond, this carbon reduce one bond. Therefore, form new bond between these two carbon, form the alkene. This is the alkene. See this one, I add the again alcoholic KOH for this molecule. This molecule have 2 halogen group. This halogen group release with this hydrogen and this one release it. Here same rule we used to use set rule. Release 2 HX molecule, reduce 2 bonds for both 2 carbon. Therefore, these 2 carbons form new bond between these 2 carbons. This is the alkyne. See this one. Here I put some CH3. This X release with this side hydrogen. This is same. Release 2 HX molecule, form 2 new bonds between these 2 carbons. Again form alkyne. Try to do this example. let's see next reaction 47. This is the alcohol, have one OH group. This alcohol have two OH group. Write the note, this one. Two OH group can't be attached one carbon. It means in one carbon can't be attached two OH group. If attach two OH group to one carbon, remove the water molecule, one OH and another OH hydrogen, remove as H2O. This carbon reduce two bonds, this bond and this carbon reduce one bond, this oxygen reduce one bond. Therefore, new bond form between oxygen and carbon. This group change to carbonyl group. Write this note, your notebook. I put as reagent concentrate sulfuric acid at 160 Celsius or Al2O3 at 350 Celsius or P2O5 or I2 and heat. This reaction we called as alcohol dehydration. When alcohol dehydration, water molecule release. This OH group combined with hydrogen release as water molecule. We use the again shade-shaped rule, which hydrogen release with, select the which hydrogen release with OH group. According to the shade-shaped rule, hydrogen, removed of hydrogen from the carbon that has the lower number of hydrogen. See this one, this carbon have 3 hydrogen, this carbon have 2 hydrogen. Therefore, this OH group releases this side hydrogen, form new bond between these two carbon. Form the alkene when we add this region for this alcohol. See this molecule have 2 OH group. All we put the same regions, concentrate sulfuric. We should put 160 Celsius or Al2O3 350 Celsius or P2O5. Put and heat the mixture, or I2 put and heat the mixture. Release this OH group, this hydrogen and release as H2O. This OH release as again H2O. Both two carbon reduce one bond, two bonds, therefore form the new two bonds between these two carbons, form the alkyl. Try to do this conversion, try to do this example, write the product for this reaction, send me your answer. I give you to conversion related this reaction. Do not use the any other, do not use any other organic compounds, any other organic compounds. Try doing this conversion. Let's see 47 reaction. I'll get alkene, put the HX as reagents. When we add the HX mean HCl, HBr, HI. When we add the HX to alkene, this 5 bond break, attach hydrogen and halogen group, these two carbon. Hydrogen attached to attach of hydrogen from the carbon that has the large number of hydrogen. Carbon that has large number of hydrogen. See this one, these two carbon, this carbon have only one hydrogen atoms, this carbon have two hydrogen atoms. Therefore, after break this 5 bond, hydrogen attached to this carbon, halogen group attached to this carbon, hydrogen attached to the carbon that has the large number of the hydrogen. This rule we called as Marconi-Koff law. Marconi-Koff law. Try to do this reaction. Doing this example and send me your answer. I give one conversion to this one. do this conversion and send me your conversion. Again I add the HX peroxide medium, HX at the peroxide medium, thus break this 5 bond. After breaking 5 bond, now hydrogen attached to this reaction, hydrogen attached to carbon that has a small number of hydrogen. See this one. Again this carbon have attached, this carbon have hydrogen 1, this carbon have hydrogen 2. When we add HX in peroxide medium, O2 2 minus medium, hydrogen attached to that carbon has lower number of hydrogen. It means after breaking this 5 bond, hydrogen attached to this carbon, halogen group attached to this carbon. Try to do this example for this reaction. Do this example and send me your answer. Again let us discuss the next reaction. I put the HOX for alkene. When we put the HOX, HOX mean HOCl, HOBr, HOI. Again break the 5 bond between these two carbon. This halogen group attached to the carbon that has large number of the hydrogen, large number of hydrogen. We see this carbon have 2 hydrogen, this one have 1 hydrogen, large number this carbon, therefore halogen group attached to this carbon, OH group attached to this carbon. Do this example. What is the product? Write what is the product when we add the HOBr for this one. Next reaction, these all reaction in one number for in the under 47. The whole reaction under the 47, OH minus KMnO4. When we add OH minus KMnO4, this reaction. Again break this 5 bond between these two carbon. OH group attached to both carbon. Next reaction is add the dilute sulfuric acid H2SO4. This reaction called as alkene hydration reaction. When doing hydration, combine with water molecule. Water molecule mean water have H plus and OH minus ions. Attach the H plus and OH minus ion this molecule. When we add the dilute sulfuric acid for alkene, this 5 bond between these two carbon, this 5 bond break and attach to hydrogen and OH minus ion for this alkene. Hydrogen H plus ion attached to the carbon that has the large number of the hydrogen. The carbon that has large number of hydrogen, OH minus attached to the carbon that has a small number of hydrogen. In this alkene, this carbon have 1 hydrogen atoms, this carbon have 2 hydrogen atoms. Therefore, after breaking this 5 bond, this carbon have large number hydrogen. Therefore, hydrogen attached to this carbon. This carbon have lower number hydrogen, OH minus attached to this one. This is the last reaction under the 47. This reaction we called as alkene hydrogenation. We use reagents H2 with nickel or platinum. When we add the nickel or platinum with H2 gas, this 5 bond break can attach to 2 hydrogen for this carbon. One for this one, another hydrogen attached to this carbon. Break the 5 bond, attach to hydrogen atom. 1 hydrogen atom, both carbon. Try to do this reaction, this one and this one. Send me your answer, all the answers in me. I will discuss the rest of the reaction, organic reaction, another video. First you should send your answers for me. After you send, I will upload another video.